Greetings viewer, I'm Alvin, and I'm pleased to announce our brand new cutting-edge football launcher!
Woohoo! Woohoo!
Wondering how we made this masterpiece? Well, look no further. I'm going to give you a demonstration you didn't even ask for, and you're gonna enjoy it. Without further ado, let's get into it. Hello, I'm a different person. Here are two views of our design sketches for our football launcher. As you can see, our launcher will have a base and an adjustable ramp connected by a hinge. Two motors will be attached to the bottom of the ramp, which will shoot the football right. In the top view, you can see where the two motors are, as well as the electrical components of the project. When everything is put together, it looks like this. Voila! Here's all the electronics in all their glory. These motors will be placed up here and screwed down later on, but besides that, that is what our end result will look like.
Hey guys, I'm totally a different person by the way. The motor control board, microcontroller, breadboard, and battery are the main components that operate our football launcher. The motor control board, shown here, serves two functions. It will connect the motors to the microcontroller and power both of them up using a 12-volt battery. The microcontroller holds all the code we created using the Arduino code and uses it to control the motors. It sends commands on when to spin them, at what speed, and which direction to spin through the wires and into the motor controller. The breadboard
Alright, that's enough. I'll take it from here. The breadboard is where we connect the two grounds, one from the battery and one from the microcontroller, into one row to establish common ground. It is also where we placed our nifty switch to turn the motors on and off. Lastly, the battery powers the entire launcher. Without it, the electrical part of the launcher will not work, leaving us with a powerless launcher that does absolutely nothing.
An important scientific concept is the idea of how thick a wire is and how it conducts electricity. For example, in this project, we have a 12-volt battery and requires wires in order for it to go to the main board, the main circuit. And the length of the wire doesn't really matter as much as how thick the cord is. The thicker the cord, the better, because in this case, this battery holds a lot of power. If the wire was super thin, then it would be too weak for it to be conduct, or in other words, the power would not be as full as it is with a thicker wire. Another important concept in this STEM project is the idea of projectile motion. It is specifically when the football is in the air, when you launch it at an angle, there's two components, the Y component and the X component. For gravity, it affects the Y component where it drags the initial velocity down. So it will make a curve when you shoot upwards and the ball will start going up and arcing over and then going down. The X component of the initial velocity is when the ball is just going horizontal. There is no acceleration for that. One of the scientific principles of this project is the idea of static friction within the motors. There's a certain threshold that must be overpowered in order for the wheel to spin. Let's say, for example, the speed of the motor out of 255, and if you set it at 70, the wheels will not rotate. And the reason is because there's not enough power for the wheel to spin. However, if you put the speed at 120, the wheel will start spinning with the noise.
Wow, that's that I guess. I hope you enjoyed seeing our development process of our launcher, and I hope to see you on the stadium. Don't get hurt everyone.